This is a product that has been in the works for over 4 months now. Our company, Piazza Hut, was founded on the idea that hybrid synchronous education lacks an effective tool for pair programming, specifically in the university system. Proposing a solution has been our main goal since the beginning. We first began with an understanding of where each member envisioned the direction that the possible solution would go. We then continued to throw ideas out, and after what felt like a very long brainstorming session, we compiled a more cohesive plan of attack. We agreed that current software tools lack the conveniences of in-person coding. As a team, we have each experienced that removing the ability to work in person creates a huge challenge to effectively and efficiently work together. There are interfaces that exist to promote pair programming activities, but they aren't developed enough in the way that they are needed as of now. Some tools have live updating or sharing, while others have camera and audio features. However, it didn't seem like there was an easy-to-use tool that encompassed all those things currently on the market. Thus, Piazza Hut has worked tirelessly to promote such a solution.
The initial design of our application was centered around the idea of trying to maintain the classic IDE look. We first imagined a design which had the project file structure over to the right of the wireframe, with the typical editor in the center of the design. We then decided to flip the file structure to the left side of the screen because most of our eyes wanted the camera box, where the partners can view each other, to be located on the right side of the editor. Providing a clickable project tree on the left-hand side of the screen for quick and easy access to project files eliminates the navigation time which would have been wasted by switching back and forth between files. This design is superior to our previous design of simply showing users the current working directory because it allows users to stay organized while helping minimize the possibility of misplacing files. Our next notable piece of evolution required a bit of productive deliberation. We decided to go with a mute button instead of a text chat box. This seemed like the appropriate choice since it was a functional and simplistic option to toggle our communication on and off. We decided that we wanted our communication to mimic working as a pair in a classroom as much as possible. Thus, if our programmers wanted to communicate, they would have to do so using their voices instead of a text box. As a result, the user is provided a mute button and no other option to communicate besides using voice chat. This reduces the learning curve of our new software drastically, while simulating the in-person, private, personal programming experience. Additionally, we believe that the speed at which a person speaks versus the speed at which a person types to be much faster and more precise. Once again, helping enhance the experience while minimizing the probability of possible miscommunications. Last but not least, we decided to implement a live update signal versus an update cursor. This update signal, much like its name implies, would show the contribution each user has made in an area located at the bottom right-hand side of the screen. We chose this over having different users' cursors appearing as different colors, because its chronological nature would help visualize the order in which changes were made. We also discovered that the different moving cursor colors would make the code look confusing, as IDEs already use different fonts for different colored fonts for different words. Using the live update signal box instead allows users the ability to see a timestamp record of when something is added to the code without cluttering up the code with distracting colorful cursors. Additionally, we noted that using colored cursors could lead to accessibility issues for colorblind users. Since our application notes when alterations have occurred, our solution accelerates debugging by allowing coders a means to backtrack to a point right before an error or problem was detected.
In our prototype, the first thing that we went about implementing was our project directory, which we chose to design using a tree structure. This file directory allows users to access different files, as well as their current ongoing projects that they have loaded into their session. Here you can see the program as we switch between the different files as well as projects that we have loaded in. Once we implemented this, our next decision was to implement a mute button that would allow users to either enable or disable the live communication aspect of our program. Once this was implemented, our final step was to implement the ability to track changes. As you can see, the track changes feature is specific to the project that is currently open. When I'm in project 1, I have the ability to see these changes. However, as soon as I switch to project 2 or 3, there are no changes present, as projects 2 and 3 do not contain any files. But once I'm back in project 1, they are visible. We chose to make this box minimizable so that users could free up space on their screen, as well as make the user interface less cluttered as a whole.
So to test the efficacy of our solution, we decided to use a combination of 3 different methods. So first, we're going to send out a voluntary sign-up to our study to a list of CS students at UGA. Then we're going to split up those CS students into pairs, and over the course of 3 weeks, at the beginning of each week, we're going to assign those students a pair programming solution, whether it's VS Code, Zoom, or our specific solution. At the beginning of each week, those students are going to join a Zoom and be split into breakout rooms into their corresponding pair. And then they are going to have to work through that coding challenge while observers who are hosting the Zoom call go between breakout rooms to kind of take notes on how participants are engaging with whatever pair programming solution they're using. At the end of each week, those pairs are going to receive both a survey and an interview invite. So in the interview, an interviewer is going to ask them questions about how they felt about using their specific solution that week, if they thought it was efficient, if they thought that it appropriately let them pair program while in like a hybrid synchronous environment. And then in the survey, they're going to be asked questions like, did you think it was easy to use? Was it easy to set up? Did you have any challenges using the software? Do you think it could be improved? But these aren't going to be qualitative answers. These are going to be quantitative and rated on a scale from -2 to +2. +2 is a positive answer or positive sentiment towards that software, and a negative response would be negative sentiment towards that software. In order to understand if our solution appropriately addresses our problem of study, we're going to use the data collected from both our breakout notes, our interview notes, and our survey results. Positive sentiment towards any one pair programming method will be weighted against negative sentiment towards that pair programming method, resulting in a sum that represents the overall sentiment towards that specific method. For instance, if a study participant scores VS Code as a -2 in usability, but a +2 in how they felt their efficiency was when using it to tackle their specific coding challenge, that would result in an overall net score of 0, meaning that they felt relatively ambivalent overall about that specific pair programming method. We're going to do this for all 3 of the pair programming methods tested in our study, and then graph all user responses against one another, hoping to produce some sort of bell curve with either a left, right, or middle lean. If the bell curve for a specific pair programming method has a left lean, that represents an overall negative sentiment towards that method. If it has a right lean, that represents an overall positive sentiment towards that method. And then, after creating these 3 graphs, we hope to overlay them onto one another. If our solution software graph has an overall more right lean of its data and a higher mean or median value, we think that that is enough to say that our solution software appropriately addresses our problem of study.
When this project first began, our group wasn't really sure what we were going to be doing. We went from just throwing ideas out to coming together on a central idea that we all genuinely cared about. We really wanted to create something that would help out pair programming, especially in a hybrid synchronous class. During this project, we learned a multitude of things, from time management skills to actual technical skills of using projects such as Adobe XD and iMovie. I'd like to start on saying one thing that we learned was the importance of having a regularly scheduled meeting time, because in the last 3 to 4 months, Thursdays at 5:30 have been our meeting time, and it's helpful in a super busy schedule to just map out a certain day where you can meet with a group. And if we were having to decide a different meeting day and different meeting time each week, that would have been terrible. And I think we all really learned just the importance of having that regularly scheduled time. Another thing that I think we all kind of learned was the importance of communicating and the importance of saying, for example, I don't think this is right, or I think we should do this better. Because I think when the project first began, we're not in a face-to-face class, we're on Zoom calls, and we didn't really want to use constructive criticism as much because we're not seeing the people face-to-face. But as we became more comfortable working with each other, I think we really learned that it's not rude to say, I think, it might be better if you were doing it this way or something like that. So definitely communication is something that we all learned and we all improved on while making this product. Something else that I think the biggest thing that we learned is on the technical side, and that is using Adobe XD. Adobe XD is a daunting program. There's so many things on it. It looks tough. It has all these different buttons. It has all these different windows, and when you first look at it, it's tough. But we went from knowing almost nothing about it to being fairly skilled in being able to use shortcuts. I'd say an example is when we first started, we would copy and paste individual elements, not as a group, when we wanted to have a screen that was similar to another screen. And I mean, as the project went on, we learned, we could group certain items together and then just copy and paste it that way. And that saved us time. I mean, that's just one example of something in Adobe XD that we learned how to use. But overall, that was a tough program to master, which I think some of us did in our group. And another big thing that I think that we learned is the importance of testing and the reasons why you need to test. I mean, I know at least personally, when we were first looking at all the things we had to do for this project, I thought that a simple survey would suffice at the end of it, and I didn't realize that we actually needed, whereas there's a lot more than just checking off boxes or saying simple sentences on a paper. There's all these different protocols that you have to adhere to. There's all these different standards and guidelines, and we didn't really know that at the beginning, and by the end we sort of were implementing that in our testing of our product. So yeah, I just will summarize the summary by saying we learned a lot of things, both technical and non-technical, while doing this project, and I think we're all going to be better software developers for having done this project.